Hello everybody, and thank you for joining us for today's webinar. My name is Nikita Perestoronin. I'm senior developer in DataAdvance. Today I'll talk about new capabilities of pSeven 5. It's a new version of our integration platform pSeven that will be released this week. The trial version will be available for downloading on our site datadvance.net. You can write your questions to the chat during the webinar. I'll try to answer all of them in the end. Recording of the webinar will be accessible on our site after the end. Since the last version, 4.3, we have made a lot of improvements in almost every part of our platform. The biggest improvements were made in integration with CAD and CAE, working with surrogate models, workflow editing, post-processing, and analysis. Major features are listed on the slides. For each feature, first I'll describe it briefly and then demonstrate it in pSeven on some example. In pSeven 5, we have added a new block for direct integration with one of the most widespread CAD-system NX by Siemens PLM Software. Its functionality is similar with other CAD integration blocks available in pSeven, SolidWorks, Creo, CATIA, and Compass. In this block, you can choose an NX part file, build a tree with part dimensions, attributes, and math properties, then map up any of these part parameters to the input or output ports. In runtime, the block will receive values of, for example, dimensions from the input ports, set them to the parts, update it, and write values of, for example, math properties to the output ports. In case of update favor, the block can stop the workflow execution or write some default values to the output ports. Also, it can export updated model to parasolid format, so it can be passed further to CAE integration blocks. Now the functionality is better. In the next versions, we're going to extend it, extract more parameters from parts, export to different formats, and support more NX versions, and so on. So let's start with a live demonstration. First, I will show you a model. It's a very simple demonstration model, just a cube with some hole inside it. So now we'll switch to pSeven. You see the edit screen where we now will create a workflow. So let's start and first add a NX block from the block library to the workflow. Press OK. Then we open a block configuration window and now we configure it. First, set some options. We need to pass to the folder where the Siemens NX is installed. So we copy it and set it. And also we want to choose the behavior of the block in case of update or export failure. There are three possibilities. We can stop the execution in case of update failure. We can send to the output port some default values that can be also set in the block. And we can write only a signal, which means that there is a special port that is named done. It's a signal port. So every block has this port, and in case of success, we write true to this port, and in case of failure, we write false. So we choose to write the false and signal. Then now we switch to configuration tab and choose this model. So it's placed in the project. So we open it, press OK. So I think we now we I just checked the path to the NX. So I think it's set wrongly, so okay. Open. Okay, so let's restart it. So okay, I will configure it from the scratch. So let's copy the path and then choose error handling behavior. Then we press apply. Okay, now it works because I think that before I just copied the path incorrectly. So the blog says that it can't find the place where the Siemens NX is installed. Now it's okay. So we press this export document button, and we get a tree with all dimensions, attributes, and mass properties from the model. And so each dimension or attribute we can map to the input port and then change it in runtime. For example, we may link it with optimizer, and optimizer will vary this dimension and, for example, recalculate the mass and send this mass to the optimizer again, and it will choose it will, for example, minimize or maximize this mass or get it to some targets. So it can be easily used inside some optimization problem. So in this simple demonstration, I just map the diameter, which is the diameter of this hole, and the mass. So and also I want my model to be exported to the Parasolid format. So I choose the name for the exported model. Press OK. Okay, so block is configured, and now I will uplink the port, which means that the input port of the model will become the input of the workflow, and the output of the model of the block will become the output of the workflow also. So I've uplinked it, and now we go to the run screen, and we see this workflow inputs and workflow outputs. So we can set, for example, some value for the diameter. Let it be 100, and run the workflow. Now it calculates the mass, and the mass is 351. So, for example, we can set the diameter to 80, and mass should be bigger because it's the diameter of the hole. So yes, now it's 360, and now I'll come back to the edit screen and check this error handling option. It says that it should write some default value in case of failover, and this default is NAN value, so it's set here. Now I will go back to the run screen and set some very big value, so the diameter of the hole will be bigger than the cube itself, so the NX cannot rebuild the model. And now I will run the workflow. And we see that the mass is NAN now. Also, we can go to the workspace screen, and here we can see our project folder, project directory, and here we can see that it exported the model to the Parasolid format to the path that we specified in the blog before. So, okay, it was a demonstration of direct integration of Siemens NX, and now I come back to the presentation. So the next feature is a significant improvement of CA tools integration. I will tell shortly about the blocks that was improved. It's a text generator block. It generates a text file by some template, substituting the specified regions of the template with values received to its input ports. And the TextParser block that parses an input file, extracting data values from the specified regions of the file and sending them to its output ports. These blocks are usually used together with a ShellScript block to integrate some CAE or external solver to the workflow. The rules for searching, substituting, and extracting are specified by means of so-called operations. These operations are generated automatically when you select the text inside the template or can be edited manually. After the rules are specified, you can set some test values for the input variables, play the operations, and check that they work correctly. In pSeven, we have improved this functionality, so now highlighting and tooltips show you where the variables were substituted into or extracted from, and which lines were found by search operations. Also, if operations finished incorrectly, for example, if some string wasn't found in template or some value extracted from the file cannot be converted to some type, for example, to integer, the block highlights a line or field where it occurs and shows detailed information about the error. You can see it on the screenshot on the slide. Also, we have improved the quick selection mode, so now it can handle with selections inside parentheses, angular brackets, etc., which makes work with templates containing markup, like, for example, XML or HTML or source code easier. Another improvement was made in ShellScript block. We have added a new command mode which allows to configure typical script using a simple wizard-like interface. You choose the path to the executable, its arguments, which also can be set through the ports, and optional as the files where you want to redirect executable input, output, and error streams. Then, from all these options, the block generates one-line shell or batch script depending on platform, Windows or Linux. Also, now you can set names for the files that will be copied to the block sandbox during the runtime. And it's useful when the executable requires files with specific names. So now come back to pSeven. I will create some simple workflow that reproduce some use case. This workflow is similar to our integration adapter workflow in our examples project, but at the same time, when I configure it, I will show some new features that I have just told. So we need 3 blocks, and now we add it from the block library to the workflow. It's generator, ShellScript, and parser. So let's start to configure the workflow with TextGenerator. So its interface, we choose a template file placed here, choose a file. And so we want to substitute these 2 values with some variables that are sent to this block from the input port. So we create this input port. It will have vector type, so with name X. And then we just select what we want to substitute and where in the template. We select it. So it uses some heuristic and generate operations which are rules for searching and writing to the template. We press OK, and now we can set some test values and check that everything works okay. So we press the execute operations button, And now we see that it was substituted with this 4 and 3 value, and the tooltip shows that it was substituted by the write operation and variable x. So, for example, we can edit the operations manually. I will show it. So we can, for example, change the format style and say that it should be substituted in specified format. So I set it, press save, and now run the operations again, and we can see that they were formatted in another way. So I think that's all with this block. So I will change it back. And now we go to the TextParser block. It has a similar interface, but now we choose some sample file, and we want to extract some values from it. We need the function values. It's this and this, and also we create the output port with the real vector type. We name it F. And also we just select the place inside this sample file, and it suggests to add the operations. So we press OK, and then we can run it and see that they were read from this place, and the operation was named read, and they were written to the variable with name F. And so we can see that they were parsed correctly. So, OK. And now we will configure the shell script in its new command mode. So we choose first the executable. A special executable that we use in our example project in our demonstration. It has the name toysolver.exe. We select it. And so this executable needs 2 files. It's a set sum file as an argument. It's an int file, and then we want to redirect its output to also some file that then be parsed by the TextParser blocks that we have just configured. So we add this in file, and then the out file. Okay, and then we insert this into the command. So the argument is in file, and then we choose to redirect the standard output to the out file. So we have just configured the command, and we can see the command preview. So it will run the toysolver.exe with this file and redirect the output to the file. So the in file will be generated by TextGenerator, and the out file will be parsed by TextParser. Okay, and now we link the ports. So the files from output to input file of shell script, and out file of shell script to the input file of TextParser. Also perform that uplink procedure. Okay. Now we have configured the workflow, and we may switch to the run screen, set some values. Run the workflow and see the answer. So these values were passed to the text generator. It substituted it to template, then sent the resulting file to the shell script. It used it as the argument of this toy solver. Then the toy solver were executed, and then its standard outputs were redirected to the file, and this file were parsed by TextParser, and now we see this parsed value. So we set X, and then we receive F, and so these three blocks can also be used, for example, inside the optimizer. So optimizer will provide the X value and use, for example, F value as an objective or the constraint value, so on. So we can change the value, run it again, and receive another answer, yes. So I think I have finished with this demonstration and can come back to the slides. So the next feature is two new dialogs for import data to file and export data from file. In import dialog, you choose path to the source file in CSV format, parsing options like delimiter, decimal symbol, comment symbol, static line, and so on. And then you select which columns must be imported. Names of the columns can be set manually or generated automatically from the file header. Then the imported data can be used and analyzed to make plots, tables, reports, and calculate statistics. Export dialog, on the contrary, is needed to save data obtained after workflow runs in CSV file. Moreover, we have done a lot of work under the hood of our plots to make them more useful and quick. Some significant improvements are possibility to set filter for every dimension in any plot, new 4-dimensional plot, that is 3D plot with additional cover axis, and reworked scatter plot matrix, which now shows not only scatter plots but also histograms and correlations, and allows to make separate plot from any element of the matrix. The edit screen was also refined. We have reworked auto validation functionality and made new issues panel, which shows you possible problems as a list of warnings and errors, and updates it automatically when you edit your workflow. And on the right side, we have placed new information panel, which shows block ports, options, and links when you select a block. It's especially useful in case of complex workflows when you receive the workflow for someone else and need to examine it quickly. So now I will show you this new panels in edit screen and these new plots and dialogs in analyze. So let's start with configuring some simple workflow. It will consist of two blocks. The first is random generator, and the second is Python script. What we want to do, we want to generate some uniformly distributed points on sphere, and then I will make a plot of the sphere, just a 3D plot to show you some new features of the plots. So we need to first generate some random metrics. Now I open the configuration window of random block and choose here the normal distribution. You know, when you can generate the 3 normal distributed vectors, and then using some simple matrix information, you will receive the points that are uniformly distributed on sphere. So it's exactly what this workflow will do. So I choose the matrix, and now I set the number of columns is 3 and number of rows is 5,000, which means that we want the 5,000 points on sphere. Okay. Also, we can see that the workflow now has 2 warnings because the Python script is empty, of course, because we haven't configured that, and output port value is not connected, which means that there is no consumer for this generated matrix, so not all block will receive it. So now we'll fix it. First, let's start with Python script block. I will just copy the simple script if you're familiar with Python, you can see that we have this Python script block, which allows to integrate any Python script inside the workflow, and you can use some Python libraries in it. For example, NumPy, which is also embedded to the pSeven. So it's a very popular library for different matrix operation. And you see that we receive this X matrix, which is random generated matrix, and using some transformation we make this matrix that is called sphere, and this sphere we will use to plot this 3D plot. So, and now let's add the variables. So it will have type real matrix. Add, and so X is input and sphere is output. Okay. Now you can see that it warns us that the value is still not connected, and also the sphere is not connected, isn't connected. And for example, I can show that if we make some error in script, it will say that the script has wrong syntax, so that's also very useful. So it helps you to detect errors before you run the workflow. So now we fix it, and let's link this value to the X. Okay, and also we will choose to save the generated matrix from Python script to the project database. So we set this monitor checkbox. It means that it will be saved in the project database, and then it can be used in Analyze to make plots, tables, etc. So okay, now it says that we have no issues, so the workflow is okay. So we can run it now. Okay. So that's all, and we can go to Analyze tab. And we didn't save it; it just have name Untitled 3, so it's placed in the project database under the tree named also Untitled 3. So now we can first make a table from these generated points. So we can see that it's matrix with 5,000 rows and 3 columns. Now we can choose it here and press 3D plots button, and we can see that it constructs some plot of the sphere. We can go to configuration and, for example, enable the color bar, choose another gradient, and choose, for example, X to be color axis. Of course, it isn't necessary to be some of the axes that are used to construct the plot. It can be, for example, some fourth dimension. So, but we just choose X for this. Also, we can give some custom names to the axis. Oh, we press OK. So the plot was slightly changed. So you can see this gradient, and also, for example, you can set the filter, and now we want only points that which X value is less than 0, and we want only points that Y value is less than 0. So we press OK, and now we see that the only quarter of the sphere was left. So, and this filter functionality now works in every plot, and we have a lot of plots here. It's two-dimensional plot, column chart, histogram, and so it works everywhere. So it's like a common interface for the configuration of the plots that we have also introduced here in pSeven 5.0. Okay, so and now we can export this generated matrix to the CSV file, and so then it can be used somewhere else outside the pSeven. So we press this export data to file button. For example, choose some CSV file name. So we want data to be separated by semicolons, and we want the columns to be named X, Y, and Z. So we press export. Now we can go to the workspace screen and select the CSV file, and you can see that it was exported correctly. So okay, and now another small demonstration. I will show you also the import dialog. So it has a similar interface. We choose the some sample, for example, here. So you can see that the first row is header, but it can detect it automatically, and so the columns are separated with a semicolon, and the decimal symbol is comma here. So we choose it. We can go to Preview tab and see that it was parsed correctly. Then we press Add to Result button and press Import. So we can see that they were imported with names, and the names were automatically generated from the header of CSV file. Now we can choose this data series, press Scatter Plot Matrix, and so now we can see the correlations and distributions of these 5 values. So, for example, we can see that, of course, it's some data. I will say some words that say some information, some indices about 40 countries, and so these indices are life expectancy, male and female life expectancy, and number of people to number of physicians, and number of people to number of televisions. So we can see that, of course, the male life expectancy and life expectancy is highly correlated, and the correlation coefficient is almost equal to 1. And we want, and we can, for example, zoom this plot and extract this element of scatter plot matrix to the separate scatter plot. Also, on the main diagonal of this matrix, we can see the histograms. And so, for example, we can here we can also zoom this plot and see the distribution of life expectancy between the countries. So this functionality of scatter plot matrix were significantly improved in pSeven 5. So okay, let's come back to the demonstration. Also, we have added 2 new features to our Proxy Player block, which is a block for working with surrogate models. First, it now can export a surrogate model to MATLAB, Max, and C formats. After it, the exported model can be used independently of pSeven. For example, you can export the model to C format, then compile it and use as a standalone application. Secondly, the block now accepts not only the points when it calculates the responses, but optionally a reference response array, which is used to evaluate model accuracy. So I will also show this functionality. I don't want to configure the workflow, I just open it and explain it. So this workflow consists of 3 blocks. It's a CSV parser that parses some test sample that contains not only the input values, but also the response values that we want to use as reference responses. Then we have this submatrix block that splits this matrix to the X sample and F sample. And also we can see on this information panel that I have just talked about that the F sample is connected with F reference port of the approx player block, and X sample is connected with X port of the approx player block. So we now can go to this block. We see that it has some model loaded in it, and this is information about the model. So its dimensionality, its options, etc. And also we can go to the options tab, and we see here an option error type where we can choose the type of an error that will be calculated when the block compares the responses calculated by the surrogate model and the reference responses. So it can be the mean error, maximum error, median, or some quantile error, or the root mean square or relative root mean square error. And by default, it will calculate mean error, so we calculate the mean error. So, okay, and we can go to run screen. We see that we set the path to the export file as input of the workflow, and as an output we receive the error of between responses and reference responses. So we can run this workflow. Okay, now we can see this error. It seems that the model is quite accurate, and also we can go to workspace tab. Since the path is relative, it means that it will be saved inside the project directory, and in the workspace tab we see this project directory, and we can find this exported file. So it has the M extension. It means that the model was exported to the MATLAB format, and it can be used independently of pSeven as a simple MATLAB function. So it can be very useful sometimes. So, okay. So now come back to the demonstration. So I think I have finished with the main part. You can write your questions to the chat, and I'll try to answer them. Okay, maybe you need some time to think and formulate your questions. You always can ask them by email, so feel free to write us anytime. Also, on this slide, you can see some useful links on our site, datadvance.net, the pSeven product page, the release notes, its documentation, and a link to the archive for the previous webinars. Also, now you can take part in some simple survey and ask our questions. It will help us to improve the further webinars.